Hi everyone. From this week, we will start learning the natural language processing. Natural language processing in its many forms has been around for more than 60 years, starting from 1950s when Alan Turing proposed the Turing test as a criterion of intelligence. The proposed tests actually include a task involving the automated interpretation and generation of natural language. However, recently it gets quite popular because there is a huge progress, the ChatGPT. So what is the natural language? We can say the English language or the Chinese language are natural language. However, the Python language is not, because it should be human language. And processing here means how a computer carries out instructions to process the natural language. Taken together, the natural language processing, or NLP, is an intersection of linguistics and computer science. It is a part of AI aiming to understand human or natural language by a program. Some common applications of NLP include answering humans' questions, analyzing sentiments in the text, or summarizing some main ideas of the documents. And the ChatGPT is quite popular these days. It also belongs to this category. And after learning this session, you should have a better understanding of such technologies. So here I list some popular applications of NLP. For example, the search engine, like Google Search, it actually uses the semantic search, which means the engine looks for not only the exact match of the query words or its variants without considering the overall meaning of the query, but the search engine can seek to improve the search accuracy by understanding the searcher's intent and the contextual meaning of the terms to generate more relevant results. Another application is translation, for example, the Google Translate. Again, the machine needs to consider the context of each word when it translates. The chatbots and voice assistants are another application. Actually, the chatbots have been coming to being for a long time. They are quite popular in the customer service. And nowadays, we also have some voice assistants like the Siri, Alexa, Cortana, etc. Here you might already noticed that when we introduce machine learning, many machine learning models like fraud detection model, classification models, they are often using the structured data, meaning they are using the numeric data or pure numbers. But for NLP tasks, the models need to be trained with the unstructured data. For example, the texts, documents, PDFs, and sometimes they are trained on videos and audios. And as I introduced before in our first or second week, the computer process using the computer language, it only understands the zeros and ones. So to process the human language, we need to transfer the text data or video data into 0 and 1 vectors. And that is called vectorization, which is a commonly used technique in NLP. Some other applications include the spell check, for example, the Grammarly, and paraphrasing, autofill. It's interesting that the NLP can also help us categorize the articles. For example, it can automatically generate some keywords for papers or some topics for the news and categorize the news into different classifications. Different classes. And yeah, it's similar that we can use NLP to do automatic summarization. yeah, if you try to use ChatGPT, you can find that it's actually really good at summarizing the knowledge because it is actually a language model, but it was trained using quite huge data, basically everything online. So when you ask it a question, it actually generates the answer by summarizing what it searched online. So that is the automatic summarization. Another interesting application is image captioning. It's a combination of not only NLP but also computer vision. To caption an image, the first step is to use the computer vision model to extract some important features from the image. And then the NLP model can take those features as inputs to train the model and use them to generate the caption. The NLP is also useful in accounting and auditing. For example, we can use them to analyze the sentiments of some documents. For example, the tweets, news, MD&A or earning calls, and other corporate filings. We can also use NLP to compare the documents, for example, to get a similarity score for several contracts to see how different are these documents. Another application is to use NLP to extract some information from a company's reports. Like we said, they can extract the sentiments. They can also extract something like the numbers. For example, how much improvement does the company achieve last year? And finally, for accounting research, the researchers often construct some new variables for their research because previously we often used the numbers or numeric data for machine learning or other predictive modeling. However, there are actually much more information in the textual data. So with the help of NLP, we can construct some new variables and use them in our previous model. And here I want to simply introduce the ChatGPT. It is a state-of-the-art language generation model developed by OpenAI. It is part of the GPT, which is quite famous concept in natural language processing, the generative pre-trained transformer. So for this model, it have revolutionized the field of natural language processing. So it's quite important. And the ChatGPT is designed to generate human-like text, making it an ideal solution for a wide range of NLP applications, like the chatbots, the language translation, text summarization, and content generation. It is quite a powerful and versatile NLP model. Its size, complexity, and ability to generate human-like text makes it an ideal solution for a wide range of NLP applications. And its potential to transform the field of NLP and improve the way we interact with technology makes it a technology to watch in the coming years. However, nowadays there are also some discussions about its pros and cons. For example, because the ChatGPT is actually a probabilistic model trained based on large data, and it makes predictions or generate answers based on the probability. That means sometimes the answer may not be the true fact, but just the most likely answers in that situation. For example, if it fills a sentence, it will fill the blank field with the most likely word rather than the right answer. So that is one potential disadvantage of ChatGPT. And because of that, I'd say maybe it's not good to use ChatGPT as search engine. However, we can use it as an assistant, for example, to help us quickly find some summary of the knowledge. Or we can use the ChatGPT to, for example, rephrase some paragraphs or let it summarize a paper's idea for us. Okay, so next I want to introduce some common tasks of NLP, including, for example, tokenization, stemming, and lemmatization, part of speech tagging, parsing, topic recognition, information retrieval, named entity recognition, sentiment analysis, text similarity. Actually, I mentioned this before. These are kind of the application. So next, I will introduce them one by one. But before that, I also want to differentiate the NLP with a relevant concept called text mining. Text mining is the process of deriving meaningful information from natural language text for further analysis using NLP. So NLP deals with data including text data, audio and video data, and many other forms. However, the text mining focuses specifically on textual data. And the text mining is very useful because most of the data today is in unstructured textual form. For example, we have so many information. We obtain so much information from emails or Twitter or search engine and the online journals. It's estimated that approximately 85% of the data today is in the unstructured textual form. In this table, I provide some intuition of the differences between text mining and natural language processing. So for the text mining, it deals with the conversion of textual content into data, which is further analysis. And NLP aims to understand the human language or text using the programs. So the human language can be the textual format or in video or audio format. And for text mining, to process the data, it uses various types of tools and languages. And for NLP, it uses high-level machine learning models to process the data and produce output. So text mining tools are quite simple. For example, it can just use a dictionary and count how many words are in those dictionary. But for NLP, we can use some neural networks like the artificial neural networks we introduced before. And yeah, so that's more high level and more complex. Then for text mining, to perform the task, it doesn't consider the semantic analysis, meaning it can ignore the situation or the context of the word, but it can just like count how many times the word appear in the sentence or in the document. But natural language processing considers the syntactic analysis and semantic analysis. So it not only considers the grammar of the sentence, but also consider the context. Another difference is the data source. The main data source of text mining is the documents, the textual data. But for natural language processing, as I mentioned before, it can be multiple sources of data such as signboards, speech, etc. And finally, text mining often outputs the pattern and frequency of words, but NLP can produce structures like grammatic structure, and it will generate more profound insights. So that is a comparison between the text mining and NLP. There is also another confounding concept with text mining. It's called data mining. Data mining actually sometimes can be interchangeable with machine learning. It can be defined as a combination of AI, machine learning, and statistics to process data in a structured form. Text mining actually can also be called textual data mining. It is the specific application of data mining that deals with unstructured data. It involves the use of NLP techniques, especially the simple ones, to extract useful information and insights from large amounts of unstructured text data, such as documents, emails, social media posts. Text mining can be used for tasks such as sentiment analysis, named entity recognition, and topic modeling. While the data mining often is used for structured databases to analyze the data pattern or build predictive models. So talking about text mining or text analysis, the text can be analyzed at different levels. It can be word level or phrase level, sentence level, paragraph level, or document level. At the most basic level, the word level, one example is that we can use text mining to count the number of times a word occurs in a document. However, naturally, we can come up with some questions. Should we also count the word's variations? For example, if it's a singular word, should we consider the plural form of the word or the verbal, the noun, and other variations? Also, should we consider its synonyms because they are expressing the same ideas? To solve those problems, the researchers have developed some dictionaries or word lists, and we can use those dictionaries to count the word. However, one disadvantage of this dictionary-based analysis is that it doesn't consider the context. It just considers how many times the word appears, but there can be some situation that a word have different meanings in different situations. So in some cases, it should not be counted. So that is one advantage of this, disadvantage of this approach. And notice that the document, paragraph, and sentences, they can also be reduced to lower level or to the word level using a technique called tokenization. Tokenization is also called text segmentation. It means the process of transforming text into meaningful units like words, sentences, topics, etc. Mostly, we segment the text into its component words. However, sometimes this can be a difficult task, and basically it's depending on the language. A good news is that the tokenization technique works relatively well in English to separate words by spaces. Except in some cases, the words can be linked together, or they are sometimes separated by a space or hyphen. And in that case, after we tokenize the sentence, the phrases can lose its original meaning. But it's more challenging to get tokens for some other languages, like the Chinese language, because in Chinese, there is no space between the words or phrases, so it would be more difficult to get the tokens. And NLP also features its syntactic analysis and semantic analysis. These are two primary techniques that lead to the understanding of natural language. The syntax is the grammatical structure of the text. So the syntactic analysis, which is also called parsing, is a process of analyzing natural language with grammatical rules. The parsing refers to the formal analysis of a sentence by a computer into its components, which results in a parse tree like this, showing their syntactic relation to one another in visual form and can be used for further processing and understanding. So here, this sentence, the thief robbed the apartment, is divided into the noun phases and verbal phases. And in this noun phase, we can divide, so this token is tagged with the DT, which means it is a determiner, and the word thief is a token tagged as a noun. So that is how we tokenize the sentence and add tags to it. And that process is called part of speech. So part of speech, or POS, or tagging, is a process to mark up the words for a particular part of speech based on its definition and context. It automatically determines whether a word is a noun or pronoun or adjective, verb, adverb, preposition, conjunctions, etc. So the POS basically explains how a word is used in a sentence. So one example is, she sells seashells to us. So for this sentence, we can see she is actually a personal pronoun. So using the POS tool, it can be tagged as, if you refer to this tag table, you can find we should tag it in PRP, which refers to the personal pronoun. And sell is obviously a verbal in third person singular form, so it should be tagged as VBZ here. And this table comes from one tool called pen treeback tag set. It is actually a classifier. It's a supervised learning. So the pen treeback actually was trained using the manually tagged data from the WSJ articles. And it said that it contains over 1 million tagged words when it was trained. And after the training, the classifier can be used on the new data, like the sentence here, to tag the words. So basically, the POS tagging is a supervised learning process that uses features like the previous word or the next words, and if the first letter is capitalized, the word's location in the sentence, etc. So these are all the features to train the supervised learning model. And after that, the model can be applied to new data set to identify the tags. So going back to the syntactic and the semantic analysis, we have the POS when we do the parsing to understand the grammar of the text. However, we still need to consider the meaning being conveyed in the text, and that is called the semantic analysis. It is the process of understanding the meaning of words, signs, and sentence structure. It is one of the toughest parts of NLP and is not fully solved yet. So understanding human language is quite complex and challenging because there are so many ambiguity. For example, there are different ways to arrange the words in a sentence. Also, the understanding of a word or sentence can rely on the context, the situation of saying that word or phrase. And the words can also have several meanings, and contextual information is necessary to correctly interpret them. And note that a sentence that is syntactically correct is not always semantically correct. For example, we can say, can we say the cows flow supremely? We can see that this sentence contains a noun, verb, and an adjective, adverb, but it doesn't make any sense. So although it's grammatically correct, it is not a correct sentence. Okay, the next technique that is commonly used in NLP and text mining is called stemming and lemmatization. These are two techniques to reduce the word to their stem. A stem is actually a part of word that remains after removing all the affixes. For example, we can reduce touching to touch, and we can reduce the argues, and arguing to argue with e or without e. So if it's without e, we are using the stemming. If it's with e, we are using the lemmatization. So this is an example of stemming, and lemmatization is more complex approach, and actually in many cases it's a better approach than stemming to determine the stem, because the lemmatization technique considers the context of the word, and it before lemmatize the word, it assigns the word the POS tag. So it first determines if the word is a noun or verb or something. So here are some examples. Using lemmatization, they can reduce better to its base form, good. And they can reduce arguing, argues, argued, argue, like we said before, to argue with E. So you can see that the lemmatization will generalize the valid words, but stemming sometimes will not generate the valid words. And a more intuitive comparison between the two techniques is this. So in this phrase, the word meeting is actually a noun. So if we use the lemmatization, it will not be reduced to meet, but it will still be meeting. But using stemming, you see it's reduced to meet. But here, in this sentence, if we consider the context, we can see that the meeting is a verb here. So using the lemmatization and stemming, we will both get the meet. So that is to say the lemmatization actually considers the context of the words and is a better approach. So why do we do the stemming and lemmatization? They are very important because if you imagine all the English words in the vocabulary with all of their different variations, to store them into a database or dictionary can take a lot of resources. So if we focus on the stem, we can develop a word list consisting different words stem and use those stem to search in the text, also stemmed or lemmatized. And that will improve the speed of the models a lot. The next technique is the named entity recognition, NER. The NER concentrates on determining which item in the text can be located and classified into predefined categories, including the names of the persons, organizations, locations, monetary values, and percentage. So basically, it's quite similar to the POS tagging. The only difference is that here, the tagged items are all nouns. Here is one example. For this sentence, Martin bought 300 shares of SAP in 2016. Using the NER, we can tag Martin as a person. We can tag SAP as organization and tag 2016 as time. And here the categories can be customized. We can also define some other categories as long as it is a noun category. So some of you might be curious, how can we use the NER? Why do we need this technique? So one popular use case of the NER is the customer support. Consider a company that receives a large amount of customer feedback and complaints. If we use NER, the company can automatically identify the customers and classify their complaints and automatically route the complaints to appropriate department or branch. And another use case is in human resources. When we recruit the candidates, we can use NER to speed up the hiring process by automatically filtering out some resumes to find the appropriate candidates with required skills or from some top universities or have specific skills or working experience in certain industries. And another technique is the relationship extraction, which is based on the NER, and it tries to identify the semantic relationship between the nouns. For example, it tries to find out who is graduate from which university or a person works for a specific company. And note that this relationship extraction problem can also be transformed into a classification problem, and a machine learning model can be trained for this purpose. Finally, this is mentioned by me for several times, the sentiment analysis. So this technique can determine the sentiment or attitude of a speaker by analyzing the text it writes. So for one example is we can use sentiment analysis to predict a customer's attitude about a product based on their reviews. And most of the time, for simplicity, we only categorize the sentiments into positive, negative, and neutral. But definitely, we can develop more categories and develop the machine learning classification models to classify the text into different groups. So that's a brief introduction of the natural language processing. In our next lecture, we invite the Professor Kevin Moffitt from Rutgers. Professor Kevin Moffitt is an expert in text mining, and he is also my professor when I learned text mining.